A pleasant greetings to all. In this video, I am going to explain important problems in root locus. The problem number 1, a unity feedback control system has a forward loop transfer function e power minus ts by s into s plus 1. Its phase value will be 0 at frequency omega 1. Which one of the following equations should be satisfied by omega 1? So first of all, find out the phase of this equation. So e power minus t j omega, put s is equal to j omega divided by j omega into j omega plus 1. Now find out the phase. Phi is equal to minus t into omega, then minus tan inverse omega by 0 minus tan inverse omega by 1. Okay, then pi is equal to minus t omega minus tan inverse omega by 0, that is tan inverse infinity. When the tan reaches the value infinity, that is tan 90 degree minus tan inverse omega. In this problem, what is given? Phase value will be 0 at frequency omega 1. So phi is equal to 0 at frequency omega 1. So minus 90 minus tan inverse omega 1. So from this equation, what is tan inverse omega 1? That is tan inverse omega 1 is minus 90, then minus t omega 1. Okay, next find out omega 1 tan of, here take minus outside, tan of 90 plus t omega 1. So from this omega 1 is minus tan of 90 plus t omega 1 is minus cot omega 1, omega 1 into t. So that is the answer. So omega 1 is cot t omega 1. And next, consider the following statements with reference to the root loci of the characteristic equation of unity feedback control system with open loop transfer function g of s is equal to k into s plus 1 into s plus 3 into s plus 5 divided by s into s plus 2. Here 4 options are given. So check the options one by one. Before checking the option, first of all, you are going to find out how many poles and zeros in this given transfer function. Number of poles are s is equal to s into s plus 2 equal to 0, 0, comma, minus 2. And number of zeros are minus 1, minus 1, minus 3, minus 5. Here, how many root locus? Root locus branches are 3 branches. Here, number of root locus branches depends upon number of poles and number of zeros, whichever is more. Okay, here 0 is more than the poles. So, number of root locus branches is 3. Okay, now, always the root loci starts from zeros and ends at the poles. Start from open loop poles and ends at open loop 0. Here 2 poles are there. 2 poles are ends at 2 zeros. So another one root loci, the pole is minus infinity. It starts from minus infinity and ends at minus 5. Okay, see here the first one, each root locus starts an open loop pole and ends at either open loop 0 or infinity. Wrong. Second one, each locus starts with open loop pole or infinity and ends at open loop 0. This one is correct. Third, there are 3 separate root loci. That is also correct. But fourth one, there are 5 separate root loci. That is wrong. So which one is correct? 2 and 3. The option A is the correct answer. Next, number of intersect of asymptote of the complete root loci. Always here the asymptote, that is meet at the centroid. So only one intersect. The answer is D. Fourth problem, if the root locus branches crosses the imaginary axis, the system becomes. Root locus branches crosses in the imaginary axis, the system becomes stable system. Fifth one, which one of the following is correct? The value of the system gain at any point on a root locus can be obtained as the first one, product of lengths of vector from the poles to the point. That is wrong. Then second one, product of lengths of vector from the zeros to the point. That is also wrong. Third one, ratio of products of length of vectors from pole to that point to the product of length of vectors from zeros to that point. That is correct. Fourth one, product of length of vector from all poles to 0. That is also wrong. Sixth one, the characteristic equation of the feedback control system is given by SQ plus 5S square plus K plus S in the X plus K equal to 0. In the root loci diagram, the asymptotes of the root loci for large K meets at the point in the S plane whose coordinates are. Asymptote always meet in the centroid. The point is known as centroid. So here we are going to find out centroid. So before finding out centroid, first we should know the open loop transfer function G of S into H of S. But the equation given is S cube plus 5S square plus K plus 6 into S plus K equal to 0. First of all, we are going to separate the value K. So, S cube plus 5S square plus KS plus 6S plus K equal to 0. And from this equation, S cube plus 5S square plus 6S plus take K outside. So, S plus 1 equal to 0. Now, you have to divide the whole. This divide by S cube plus 5S square plus 6S. So, what is the equation we get? 1 plus K into S plus 1, the whole divided by S cube plus 5S square plus 6S equal to 0. So 1 plus, what is the characteristic equation? 1 plus G of S into H of S equal to 0. So here what is G of S into H of S now? So G of S into H of S, that is equal to K into S plus 1, the whole divided by S cube, take S outside, so S square plus 5S plus 6. Now I have to separate this. So K into S plus 1, the whole divided by S into, have to separate this equation. So S plus 2 into S plus 3. Okay, now find out the number of poles. So number of poles are, what is number of poles? Number of poles is 0, minus 2, minus 3. Number of zeros are number of zeros. Zeros are minus 1. And next you have to find out the centroid. So what is centroid now? Centroid is sum of poles minus sum of zeros divided by number of poles minus number of zeros. Okay, see here sum of poles is 0, minus 2, minus 3, minus of, minus 1. Okay, divided by number of poles. How many poles? 3. Number of zeros? 1. So, minus 2, minus 3, minus 2, minus 3, minus 5. Minus 5 plus 1, minus 4. The divided by 2. So, what is the answer now? Minus 2, 0. The answer C is the correct answer. Next. The characteristic equation of the control system is given by S into S plus 4 into S square plus 2S plus 2 plus K into S plus 1 equal to 0. What are the angles of asymptotes for the root loci for K greater than or equal to 0? Here also first we have to find out the open loop transfer function like a previous one. So first separate the K term. Here K term is already separated. So no need to separate the K term. and now we are going to find out the open loop transfer function. So open loop transfer function, g of s into h of s equal to k into s plus 1 the whole divided by s into s plus 4 into s square plus 2s plus 2. Okay, here how many zeros? Zeros are 1. How many poles? Poles are 0 minus 4. Here we get 2 poles, 2 imaginary poles. So 2 numbers of poles. The total number of poles are 1, 2, 3, 4. That is 4 numbers of poles. And next find out asymptote. So before finding out asymptote, find out how many asymptote for this given root locus. So number of asymptote is n minus m. N is number of poles minus number of 0. There are 3 asymptote. 3 asymptote starts from 0, 1 and 2. So what is the formula to find out asymptote angle? Asymptote angle is equal to plus or minus 2q plus 1 into 180 the whole divided by n minus m. So 2q means q is equal to 0. 2 into 0 plus 1 divided by 4 minus 1. 3 into 190. Here plus or minus. So first angle is 60. So 60 plus or minus 60 is the first angle. So next find out the second angle. So for the second angle put q is equal to what? 1. So q is equal to 1, we get the second angle. So second angle is 2 into 1 plus 1, 3 by 3, and second angle is plus or minus 190 degree. And next find out the third angle. Third angle put what? 2. 2 into 2. 2 into 2 plus 1. So 5 by 3 into 190. So 360. So answer is plus or minus 300. So three angles are plus or minus 300 degree. So three angles are 60, 190 and 300. Next, consider the following statements made on the basics of root locus analysis. The first one, intersection of asymptote must always be in the real axis. The intersection of asymptote, that is centroid, always in the real axis, correct. Then second one, the asymptotes of root loci refer to the angle of root loci when k is 0. That is wrong. So answer is 1 only. Next, a unity feedback system has an open loop transfer function g of s is k by s square. The root locus plot is. So, to draw the root locus plot, you should know how many poles and how many zeros. So, zeros are 0. Poles are how many poles? 2 poles. 2 poles are 0, 0. And next, find out the centroid. So how to find out centroid? Centroid is addition of poles minus summation of zeros. Number of poles and zeros 0 and 0 by 2. Centroid also 0. And next, asymptote. So asymptote angle. So asymptote angle is how many asymptote angle here? 2 asymptote angles 0, 1. So asymptote angle 1 is plus or minus 2 into 0 plus 1 divided by 2 into 190. Okay, here first angle is plus or minus 90 degree. In the similar manner, what is the second angle? A2 is plus or minus 2 into 1 plus 1 divided by 2 into 190. So second angle is 2 plus 1, 3 into 90 plus or minus 270 degree. Okay, see here for the second one, 2 poles in the origin. So 2 poles are marked in the origin. So this is correct. And centroid also 0. This is also correct. But third one is asymptote 90 degree. 90 degree, this is plus 90 and this one is minus 90. So option B is the correct answer. Problem number 10. Which one of the following statement is not correct? Root loci can be used for analyzing stability and transient performance. Correct. Second one. Root loci provide insight into system stability and performance. That is also correct. Shape of the root locus give the idea of type of controller needed to meet design specification correct. But the last one, root locus can be used to handle more than one variable at a time. That is wrong. So, but this is the correct answer for this problem. So, answer for this is D. D is the correct answer. Thank you. Have a nice day.